Right, here's part 2 of the June 2014 R M2 paper, EDEXCEL. So we're at question number 5, and the potential energy lost, because we've got a right angled triangle, that's 5, this is 30, so this length here is 5 sine 30, which is 2.5. So the potential energy lost is mgh. M we know is 2, G we know is 9.8, and H is 2.5. So work that out, that's 49 joules. So now we're on to part B. It's moved down the slope. So after it's moved down the slope, it's got kinetic energy and it's done work against friction. So that's half times m times v squared plus force times distance. So that's a half times 2 times 4 squared plus the force multiplied by 5. Initially it had potential energy, which worked out to be 49. So 49 is a half times 2 times 4 squared plus 5f, and solve that equation and we get 6.6 newtons. That was B part 1. Now let's look at B part 2. We've got a weight of 2g. The component of weight there is 2g cos 30. So the normal reaction is going to be 2g cos 30. We know that the force is 6.6, and we know F equals mu times N. So mu must be 6.6 over 2g cos 30, and that works out to be 0.39 to 2 sig figs. And finally in part C, once it gets to B, it's got kinetic energy and it's done some work. So that's half times 2 times v squared plus force times distance. And where has it got this energy from? From the potential energy that it had at the start, plus of course the kinetic energy. In part A and B there was no kinetic energy at the start, but initially there was potential energy and there was kinetic energy. So the potential energy is 49, as it was, and the kinetic energy is half mv squared, so that's 3 squared. So therefore we can equate these two. A half of 2 is 1, so that's v squared plus 6.6 times 5, that's 33, is 49, half of 2 is 1, 1 times 9 is 9. So v squared is 58 minus 23, which is 25, that's nice. So the square root of 25 is 5. Now on to question 6. We've got a speed of 25, we've got alpha, so we know that sine alpha is 4/5, so cos alpha is 3/5. We can do suvat in 2 dimensions, so that's s-u-v-a-t. No acceleration horizontally, minus 9.8 vertically. At the initial speed is 25 times cos alpha, which works out to be 15, and vertically is 25 sine alpha, which works out to be 20. At the highest point the speed is 0, so we can use v squared equals u squared plus 2as vertically, so 0 equals 400 minus 2 times 9.8 is 19.6 times the distance, which we'll call y. There's a y there. So y is 400 over 19.6, which is 20.4. But read the question. It says the particle is projected from a point 10 metres above the point O. So therefore the greatest height is that 20.4 plus the 10 it had originally. So that's 30.4 metres, or 30 metres to 2 sig figs, since we're using G to 2 sig figs. Now let's look at part B. So we need to do a similar thing. SUVAT. We were trying to find out the horizontal distance. We know the vertical distance is -10. We had 25 cos alpha was 15 and 25 sine alpha was 20. That's 0 and minus 9.8. So let's work out t from the vertical component. So S equals ut plus half at squared. So minus 10 is 20t minus 4.9t squared. So there's a quadratic equation to solve. 4.9t squared minus 20t minus 10 is 0. Use the formula and we get a positive and a negative value. The positive value is 4.532. So now let's put that into the horizontal component. We can again use S equals ut plus half at squared. We know that horizontally a is 0, so therefore y is 15 multiplied by 4.532, which works out to be 67.979, which 2 sig figs is 68. Now we've got part C. If we think about the initial speed, we know that that angle here is alpha, and then we've got a point at C where the direction is at right angles to it. So this angle here is 90 minus alpha. So if the particle is moving in this direction, then we can think of that angle there being 90 minus alpha, which means this angle here is alpha. So let's call this speed v. This is v cos alpha, and this is v sine alpha. So let's do another SUVAT in 2 dimensions. SUVAT. So we know that u is 15 and 20. We know a is 0 and minus 9.8. We've just said that v is v sine alpha and minus v cos alpha. Clearly, because a equals 0, we can say that v equals u plus at, therefore v sine alpha equals 15, therefore v is 15 over sine alpha, which works out to be 75 over 4. Let's now use that information in the vertical component. V equals u plus at, so minus v cos alpha equals 20 minus 9.8t. And if you solve that equation, we need to find out what v is, we need to know what cos alpha is, so therefore 70 minus 75 over 4 cos alpha, which we know is 3/5, equals 20 minus 9.8t. Now we can solve that equation. T works out to be 3.2 seconds. 2 sig figs. And now number 7. 2 particles, P and Q. The mass, we need a mass, we need the initial velocity, final velocity for each one. So it's 2m and 3m, it's 3u and minus u, it's vp and vq. As always, don't bother putting the minus sign in yet, we'll deal with that later. We don't know what that is, the mass will take care of it. So conservation of linear momentum tells us that 6mu minus 3mu equals 2mvp plus 3mvq. And then the E equation tells us that E equals VQ minus VP over 4U. So we've got equation 1 and equation 2. We want to find out what VQ is, so let's get rid of VP from here. So let's take equation 2 and write VP as the subject of that equation. It works out to be VQ minus V 4UE. And let's substitute equation 3 into 1, and we get 3mu equals 2m, but instead of VP we can write VQ minus 4UE plus 3mVQ. So let's get rid of those brackets. 2mVQ minus 8mue plus 3mVQ. So we've got 2mVQ plus 3mVQ. I reckon that's 5mVQ. So let's put that over here. And then we've got 8mue and 3mu. Let's put that over there. M and U are factors. So it's mu and it's 3 plus 8e. Obviously the m's cancel. So we get VQ equals U over 5, 3 plus 8e. As required. Now we're going to need VP in a minute, so we know from part A that VP is VQ minus 4UE, and we know that VQ is U over 5, 8e plus 3. So that works out to be 8ue over 5 plus 3u over 5 minus 4eu, which is 3u over 5 minus 12eu over 5, which works out to be u over 5, 3 minus 12e. So we'll use that in a minute. Now, we know that VP is negative. Then u over 5, 3 minus 12e must be negative. U is not negative, 5 isn't negative, therefore 3 minus 12e is negative. In other words, 3 is less than 12e, in other words, e is greater than a quarter. So therefore the range of values of e are between a quarter and 1. The mark scheme specifically says you must put in this 1 here. E is always between 0 and 1. It could equal 0, it could equal 1. And finally, let's think about the kinetic energy. The kinetic energy beforehand is a half m v squared, yeah. So 3u squared is 9u squared. And for q, it's 3m, and then it's just u squared. So that works out to be 21 over 2 mu squared. The kinetic energy after is a half 2m vp squared plus a half 3m vq squared. So a half of 2m is m. Vp we know is u over 5 3 minus 12e squared, and a half of 3m, that's 3m over 2. Vq we know is u over 5 8e plus 3 all squared. But we know that E is a half, so therefore the kinetic energy after is mu squared over 25, and then we need to put in a half into here. 12 times a half is 6, 3 minus 6 is minus 3 squared is 9. Then we've got 3mu squared over 2, no we haven't, it's 2 times 25, which I reckon is 50. 8e plus 3, 8 times a half is 4, 4 plus 3 is 7, 7 squared is 49. So this works out to be 9 mu squared over 25 plus 147 mu squared over 50, which works out to be 165 mu squared over 50. And that cancels down to be 33 mu squared over 10. 5 times 33 is 165. So the kinetic energy the kinetic energy before is kT over T, which is K, and we know that after is 33 mu over 10, and before is 21 mu over 2. I seem to have lost some squareds there, so it's there. So that's lucky because m cancels, u squared cancels, so we get 33 over 10 multiplied by 2 over 21, which is 66 over 210, which is 11 over 35. Sorry about the muck up with the u squareds, but that's not a fiddle, that's the correct method. Now it looks correct. And that's the end of the paper.